Hello, everyone, one more time. Thank you for joining another session, Flat and Learn Networking Broadcast. And today we will talk about how to build the Layer 3 data center interconnect. Again, my name is Jiří Chaloupka. I'm Cisco Technical Marketing Engineer, and we are focusing again on some interesting and technical topics from the networking. So first, the objectives. Let's first look at like layer 2 versus layer 3 role in the EVPN. We will be really focusing on the layer 3, mainly on the DCI, as I mentioned. We will look at the fundamentals. Why VRF? Why terminate the service on the DCI? Why it's very important to most of the time do it. We look at the different control plane options. We will again compare VPN v4, VPN v6, and the EVPN. This time again for the layer 3. We discussed about this the options during the first session. So we will remind a lot of things there, and we will also look at like a different data plane options. We will talk about like mainly we will be covering the MPLS, but we will also look at how is the difference between the VXLAN and, for example, SRv6 when we will look at the IP data plane. So first, if you remember, the 2 weeks ago we had a session where we quickly talked about distributed anycast gateway. You see the picture on the left side, where basically we are terminating. We have the layer of the L2 on the between the leaves, and we are configuring the distributed anycast gateway to the IRB. And basically, we are terminating the layer 3 service directly on the leaf. So basically, all the communication from the leaf to DCI can be already layer 3. This is something what we call distributed anycast gateway. On the other hand, on the right side, you can see another option where you have a IRB on the DCI. So basically, your leaf layer is purely L2, and you are doing the centralized routing. This is very, very important to understand that when we will really terminate the L3 layer on the leaf, we really don't have to configure any bridge domain, and we can on the DCI, and we can really focus on the DCI just purely on the routing on the layer 3. So this is like the main difference between the distributed and the centralized gateway. And now we will be really focusing on the use case left side where we have a distributed anycast gateway. So most of the time, as I mentioned, you will need the DCI. Even if you will have the same data plane in your DCCO or in the core, you will need to terminate the VRF or basically your service on the DCI, because you will need to summarize the prefixes. Yeah, and on the next slide, I will talk about more the details. So what important thing is here that even if you have a same data plane in the core as well as in the CO, you cannot just basically downgrade your DCI to the P role or spine role if you want. Now the question is why? What is the main reason that I'm terminating the service directly on the DCI? So the first, let's look at really the forwarding table. Let's for a second forget completely the control plane or the data plane. Let's just look at the forwarding information which each router needs to have in the FIB. So let's when we will look at on the leaf layer here, we have 4 leaves. We have 2 hosts. Let's say that both of them are sitting in the orange subnet, and basically I have this subnet stretch between these 4 leaves. So basically H1 is sitting behind the L1, L2, H2 is sitting behind L3 and L4. But we look at from the forwarding point of view, for example, on the DCI, normally when you would take like the VPN v4, the prefix, you would see like hold the prefix XXS/24 over leaf 1, leaf 2, leaf 3, and leaf 4. This would be normally like the BGP multipath, But in this case, you need to see the host route of H1 and H2 to be able to send the traffic to L1 and L2 for H1 and to L3 and L4 for the traffic for H2. So basically, you have to really install the host route. Now the question is, okay, so when I will basically postpone it, I will for a second forget how I will have a transport. Like let's say that I have really end-to-end single domain IGP transport from the remote PE3 router. I would have to go right now and I would have to install all these host routes for the H1, H2 in PE3 forwarding table. It's for sure possible, but most of the time this will not scale. So what we are doing very often is on the DCI layer, on DCI1 and DCI2 in this picture, we will install the host routes to the FIP, but we will we basically re-advertise the routes towards the PE3 with the next hop to DCI. So basically, you can see on the picture that I don't need right now the host routes of the DCI1 and DCI2 on the PE3 layer. Basically, on the PE3, I have just the summary route, basically prefix pointing to DCI1 and DCI2. And for opposite side, I have some remote prefix ZZZ /24, which I'm advertising to DCI, and completely same DCI is re-advertising this prefix towards the CO. So basically, you can see that all the leaves are pointing. Basically, they have a next hop for ZZZ /24 to DCI1 and the DCI2. So basically, the DCI will receive and will re-advertise. Now let's look at the possible options. How I can do this advertising. So in the end of the day, we have 3 options today. And if you look at all the standard options, we are focusing on the BGP control plane. So from the BGP, excuse me, from the BGP point of view, I can use the VPN v4 or VPN v6 address family in the CO, or I can use also the VPN v4 and VPN v6 address family in the core. So this is definitely one option. Another possible option is to use the BGP EVPN for advertising these L3 informations really end-to-end. So I will have EVPN between my DCI and leaf layer, and then also from my DCI to remote PE3 layer. Third option is that I have, for example, EVPN in the CO, and then I have VPN v4, VPN v6 in the core. Of course, I can also flip-flop it, but in the end of the day, it will be same use case. But most of the time, you really need to have EVPN in the CO because you are running already the EVPN for the L2 stretch between L1, L2, L3, and L4, right? So in the CO, the EVPN will be there. Anyway, we are right now talking about the communication from the leaf to DCI, from DCI to PE3, and from the opposite direction. So again, we are expecting that there is EVPN between the leaves anyway. So right now, let's very quickly compare these options. So first one is that basically I'm really getting the VPN v4 prefixes from the leaf to the DCI. And again, when I'm saying VPN, I'm showing VPN v4 here on this picture. I'm also is completely same for VPN v6. Basically, I'm advertising the hold the prefix in the VPN v4. In this case, you can see that first I will advertise from the PE3 to DCI, and then DCI is re-advertising to the leaves. Then from opposite direction, also hold the prefix is advertised from the leaf, and then is re-advertised to the PE3. But here is a very important thing that I need to also advertise, as we discussed, the host routes for the H1 and H2, which I will advertise on the DCI. But the DCI is not re-advertising these host routes. DCI is advertising just the hold the prefix. That was the first option. So let's look at the second option. The second option is that when I'm using the EVPN address family relay end-to-end. So here in this case, what I'm receiving route type 5 from the PE3. Basically, hold the prefix on the DCI, and on the DCI, I'm basically advertising the EVPN route type 5 hold the prefix to the leaf. And the same is happening from the opposite direction. So I'm taking all the prefix advertising from the leaf layer, getting it on the DCI, and there I'm re-advertising it again towards the core. And here, because in the EVPN, as we discussed the last time, I'm using the route type 2 for advertising the host routes. So in the route type 2 from the leaf layer, I'm advertising the host routes towards the DCI. And the same, like from the same as the previous example, I will install this host route on the DCI, and I'm not advertising it towards the core to PE3 because again I have just the summary route. The third option is that basically I'm combining the VPN v4 and VPN e6 with the EVPN. So here in this example from the PE3, I'm sending VPN v4, hold the prefix on the DCI, and from the DCI I'm advertising it as a route type 5. So basically I'm using the opportunity that I have a same control plane, same control plane, which is a BGP. I have just a different address family, and I'm basically advertising between two different address families. From the opposite side, again, I'm receiving route type 5 from the leaf, and I'm re-advertising it as a VPN v4 update towards the core. And the last one, again, I'm receiving on the DCI the route type 2, and I'm not advertising this because I have just a summary route. I'm just installing this host route to the forwarding table. Let's right now compare these three options, because we discussed like the first one where I have a VPN v4, VPN v6, and VPN v4 and VPN v6 interconnect. So what are the pros? The very important VPN v4, VPN v6 is industry-proof solution for layer 3 VPN. I think that there is no doubt that this is something what is on the market quite a long time, and it's definitely proved solution. DCI doesn't need to understand BGP EVPN address family, so basically the DCI is completely clueless about EVPN. All the EVPN is terminated on the leaf layer. What is a little disadvantage is that leaf has to peer with a router reflector via both address family, EVPN as well as VPN v4, VPN v6. Again, because EVPN address family is there to anyway support L2 stretch between the leaves. So you have to run the EVPN anyway between the leaves for make advertisement inside the CO, and also for the ARP and the synchronization for multi-homed all active access, as we discussed in the review session like 2 weeks ago. The next one is that your DC or CO router reflector has to support both BGP address family, obviously, because you need to have a peering for the EVPN as well as for VPN v4, VPN v6. And here you need to have ability on the leaf layer to advertise the host routes in the VPN v4 or VPN v6 address family. The second option is to have this EVPN and EVPN end-to-end, as we discussed. So you have a single BGP address family end-to-end in the network. This is definitely like the benefit, because you don't have another address family. On the other hand, you have to go and you have to touch all your existing VPN v4, VPN v6 services in the core to migrate them to the EVPN address family. And this is, in the end of the day, like the EVPN here in this example, when it's purely L3, is not bringing any benefit in the core. So basically, on the remote PE, when you will migrate from VPN v4, VPN v6 to EVPN, and you are really holding just the L3 VPN service in this example, don't take me wrong, when it will be L2, it's completely different. But in this example, when it's L3, there is no technical benefit to migrate from the VPN v4, VPN v6 to EVPN. Basically, you are just using the different encapsulation for the information which you are sending, as we were showing on the previous slides. The third option is to basically use the existing VPN v4, VPN v6 in the core when I'm a pure L3 service, and then I'm using EVPN only in my CO. This is our recommended solution because we are taking a benefit basically from the both. As we discussed, EVPN is in the CO anyway for the L2 stretch, ARP, and desynchronization. So you will run the EVPN there anyway. So you have route reflector is also running only on a single BGP address family. And also in the core, your existing services are staying untouched. So basically, you are really using the benefit of both, using the benefit of having the L3 existing VPN in the core, and also like using the EVPN address family for all the options which you have with the EVPN in the CO. So now let's very quickly look at the forwarding. How look at the forwarding with the MPLS data plane. We said that we will also look at the different data plane options. So here in this case, when we talk about end-to-end MPLS, doesn't matter if you are using the VPN v4, VPN v6, or you are using EVPN for L3. This is just a really control plane, right? So from the data plane point of view, if you will do the packet capture from the wire, you will get always completely same packet. So in the end of the day, from the packet capture, you will don't know if the information was exchanged over the VPN v4 or EVPN when we talk about layer 3 in this case. So when I'm sending the packet from the PE3, first, I will impose the transport label of DCI1, DCI2, and another label will be the service label, typically VRF or the prefix label. It's just about allocation of the label inside the VRF, and then I have the original IP packet from the C with destination address, in this example XXXH1. I will arrive on the DCI because of the PHP. The top label will be the VRF label. I will do the lookup, and I will see that H1 is basically sitting behind L1 and L2. Here, it's again very important that we have the host route on the DCI1 and DCI2, because when we would have just a summary route, we would not DCI wouldn't know if to send the traffic to L1, L2, L3, L4, because it would be basically the multipath from the prefix point of view. So we know that we have to send the traffic to L1 or L2, so we will do the BGP multipath, and we will basically, in this case, we will choose L1 or L2, and we will again impose the transport label of L1, L2, the VRF label or service label for this particular prefix or particular VRF, and again the original IP packet. Again, we will on the spine we will do the PHP. We will send the traffic to L1, L2 based on the transport label. L1 will do the lookup and will forward to the H1. We will take it from the opposite direction. From the opposite direction is completely same. So again, L1 is sending the traffic to DCI. DCI will do the lookup and will again send it to the PE3. When we look at like the label stack, it's completely same from the left to right and from right to left. Again, I'm always going first to the DCI, doing the lookup, and then I'm going to the PE3. Why I'm going to the DCI first? Just a reminder, it's because of this host route, and I want to summarize the prefixes towards the core. Otherwise, it would not scale for me. Now the option where I have the MPLS in the core, and then I have a VXLAN in the CO. So first, I'm sending the packet completely same from the PE3 to my DCI as before, but here the DCI has to change the data plane. So what's happening here again? I have my IP header of the leaf 1, leaf 2, because VXLAN is the IP packet. Then I have my the VXLAN header, where basically I'm imposing mainly the most important information is the VNI, which is it's just it's like the VPN information for the VXLAN. And then I have my inner packet here. What is very important, based on the RFC 7348, I have to also impose the inner Ethernet header. So basically, I have to impose inner Ethernet header for this packet XXX H1 destination address and send it to the leaf. From the opposite direction, it's a very similar. Leaf 1 will send the packet first to the DCI, and DCI from the VXLAN will also do the the interconnect to the MPLS. So again, just a different data plane in the CO. Then I have next option is to use, for example, SRv6 end-to-end. What will happen here? The basic example will be that again I will have my IPv6 outer header to DCI1, DCI2, and basically because I'm able to encode all the informations about the transport as well as the service to the IPv6 outer header. I'm sending this to the DCI, and next is directly the original IP packet, and on the DCI again I'm sending the traffic from the DCI to leave. Again here in this example to leave 1 or leave 2 because I'm doing the lookup for the destination address H1. And again, I'm encapsulating to the SRv6. It means that I have just the IPv6 outer header. From opposite direction, completely same. From the leave to DCI, from the DCI to PE. Again, the packet structure is completely same. So let's same like we compared before the control plane. For the EVPN L3, let's compare very quickly the MPLS or the MPLS and IP data planes. So first, the MPLS, the packet structure is always identical regardless of BGP, VPN v4, VPN v6, or L3 VPN control plane. This is something what we already mentioned. It's very important for the complexity. Very simple troubleshoot. As it's on the picture, you have always the transport label, then you have a VRF or your prefix label and original IP packet. Same load balancing mechanism. The time in your CO as well as in the core. Typically, what you can do is that you are doing the inner IP header lookup. So basically, each P router or a spine router will look at the inner IP header, will do the hash, and based on this, you will have the balancing inside your core or inside your CO. If you remember, last time we discussed the Jose Lista introduced the segment routing, the MPLS. So when you will use the segment routing for the MPLS data plane, you can provide also the traffic engineering. You can have a faster route. So, and for example, from the faster route, you can benefit in the core as well as in the CO. This is a little heavy slide. I apologize for it, but I wanted to have like the IP data plane information on the one slide. So first, here is the as we discussed the VXLAN data plane option. You have for the VXLAN only one signaling option is the EVPN. For the VXLAN, there is no VPN v4, VPN v6. Based on the RSC 7348, there must be the inner Ethernet header as we discussed. So this is a little overhead because we are really doing the L3 forwarding. So there is not necessary to use the inner Ethernet header. Very often this inner Ethernet header calls that you have to basically on the DCI implement the bridge domain and basically process this inner Ethernet header. Theoretical option is also to use the VXLAN GPE, which is removing this inner Ethernet header. But based on the RFC 7348, you have to impose this inner Ethernet header. The next one is the SRv6, where basically, as we discussed, transport and service is basically integrated. Is programmed to the outer IPv6 header. When we will take really basic example, so I have just IPv6 header, and then I have my original packet. I also don't need to have any UDP header as a, for example, for the VXLAN when I'm using the IPv4, because UDP header I'm using for the load balancing. Here, because it's only IPv6 for the load balancing, I'm using my flow label in the outer IPv6 header. And very similar like MPLS, the packet structure is all the time same. Yeah, so doesn't matter if I'm using for the signaling the BGP VPN v4 VPN v6 or EVPN address family. Basically, it will be same. It's very similar like when we were comparing the MPLS data plane. SRv6 doesn't require additional header compared to the VXLAN, so we don't have any VXLAN header. We don't need to have this inner Ethernet header. So basically, that's another benefit. And same principles when the segment as for segment routing MPLS, right? So it means that you can use also optionally segment routing header, which will provide the traffic engineering, service chaining, and you can also use all the benefit of the fast reroute in the CO as well as in your core. So let's very quick. Let's do very quick conclusion. The data center interconnect is very often required for IP summarization. Why IP summarization? Because I need to scale. This is the most of the time the reason why it's good to do the layer 3 interconnect, because on the DCI you can really summarize your IP addresses and you can really advertise just the summary prefix. This is the way how you can scale on the DCI and basically also like in your CO or in your DC. If you will not do the summarization, you can definitely, theoretically, it will work, but your remote PE or your remote DCI will have to install all the host routes from your CO. So basically, you are really getting close to the having all the MAC addresses, like you are doing this basic L2 stretch across multiple data centers. You have to install also everything everywhere. Here it's very similar. You have to go even for the L3, install all the host routes everywhere to be sure that you will forward to the proper leaf. So very often the IP summarization is required on the DCI layer. As we learn here, the EVPN is really not strictly replacement of the traditional VPN v4, VPN v6. EVPN is very powerful, but it definitely makes sense to use it where it really playing the key role. So basically, definitely when you have your traditional L3 VPN service, your VPN v4, VPN v6 today, it's better to think twice if you want to go and you want to really replace it by EVPN. You can definitely do it, but EVPN is bringing mainly the benefit of having L2 stretch, combination of L2 and L3 at the same time, as we discussed during the session 2 weeks ago. So really, you can also use the benefit that both of them are BGP, and you have a very simple way how to basically distribute the information or legal information between the VPN v4, VPN v6, and EVPN. Service layer is data plane independent. As we learned very often, like for example for MPLS and for SRv6, when we are using the segment routing, then completely doesn't matter if I'm using from the data plane point of view, I'm using EVPN or VPN v4, VPN v6, but at the same time, the right data plane selection can increase complexity and provide additional capabilities, as we discussed. SR MPLS can offer you fast reroute. SRv6 can also offer fast reroute, can offer service chaining, and so on. So there are like a different options in terms of the programmability. And we will also about this programmability part. We will talk about the next sessions of this Flat and Learn. So if you will be the following the next sessions, you will get a more clarity why, for example, this SR MPLS and SRv6 is interesting data plane option. So that's it from my side today. Again, I try to be really, I try to make a really short session to have it really with the condensed amount of the information. If you want to again learn more about EVPN, go just to the e-vpn.io, and you can also check for the next networking broadcast. We didn't publish the agenda yet for the next one, but it will come soon. Again, I will post this presentation on flatlearn.io. You could realize that we have a new web page, and I will also try to publish the recording as for the previous session. So one more time, thank you very much for the joining, and hopefully see you soon during the next Flutter and Learn networking broadcast. Thank you.